The universe today is vibrant and thriving, filled with exciting phenomena and endless possibilities. But one day, the nights will turn dark. Everything that once was will peacefully fade into eternal stillness. Yet, there will be a final event, the last thing to ever happen. To understand this, we must journey to the distant future of the universe. The journey begins. After a chaotic birth, the universe was a quiet, swirling infant, brimming with hot hydrogen and helium. Its story is one of creation, destruction, and transformation, an endless cycle dictated by the fate of its gas. As the universe matured, the first generation of stars emerged. These massive, short-lived giants forged new elements and spread them across space when they exploded. Successive generations of stars recycled this material, refining it, and passing it on. However, not all gas was returned. With each new generation, an increasing number of red dwarfs formed. These small, long-lived stars burn for trillions of years, and when they die, they become white dwarfs, locking up gas forever. Neutron stars and black holes also trap material permanently. Slowly, the universe's ability to create new stars diminishes. The dimming of the cosmos. For billions of years, the universe will remain a spectacular place, teeming with potential for exploration. But as time passes, large stars and sun-like stars will perish. Eventually, red dwarfs, once the most common stars, will burn out. The last stars to form will be few and far between, and eventually, star formation will cease entirely. In a few trillion years, cosmic gas will be exhausted. At that point, 88% of the mass in every galaxy will be white dwarfs, 2% neutron stars and black holes, and 10% brown dwarfs and gas giants. White dwarfs, the dim remnants of dead stars, are incredibly dense and gradually cool over time. Their surfaces can start at temperatures as high as 150,000 degrees but will eventually fade into darkness, becoming black dwarfs, cold, inert spheres blending into the void. Over the next quintillion years, galaxies will disperse. Gravitational interactions will eject most objects into intergalactic space or send them spiraling into supermassive black holes. The universe will become an isolated expanse of wandering celestial corpses. The death of black holes. Even in this desolate era, something still happens. Black holes will slowly evaporate due to Hawking radiation. Over the course of a mind-boggling 100 years, the last supermassive black hole will finally vanish in a burst of light. Any hypothetical civilizations clinging to existence around these objects will be gone. The universe will be dark, empty, and silent. The age of black dwarfs. Yet, an even more astonishing process is unfolding in the shadows. Black dwarfs, frozen remnants of white dwarfs, are as massive as stars but as cold as space itself. They remain intact due to electron degeneracy pressure, which prevents their collapse. However, quantum mechanics dictates that, over time, particles can tunnel through energy barriers and interact. This means that, albeit at an incredibly slow pace, nuclear fusion can still occur inside these frozen husks. Trillions upon trillions of years will pass with no noticeable changes. Then, in one rare instance, two carbon nuclei will quantum tunnel and fuse into magnesium. After another unfathomable stretch of time, another fusion event occurs. Slowly but surely, these processes create heavier elements within the black dwarf's core. Eventually, after an inconceivable 1,500 years, fusion will create nickel-56, a radioactive isotope that decays into iron. This decay emits positrons, which annihilate electrons. Electrons are crucial for supporting the star against gravity. As more electrons are destroyed, the pressure holding the black dwarf stable weakens. The final supernova. At long last, after 10,000 years, a span of time beyond comprehension, the last remaining black dwarfs reach their tipping point. They can no longer resist their own gravity and collapse. The final act of the universe unfolds, a supernova. For the last time, light fills the empty cosmos. A magnificent explosion momentarily breaks the darkness. It is a beacon in the void, but there is no one left to witness it. The last event in the universe has occurred. Then, as suddenly as it arrived, it is gone. The final spark fades. Darkness reigns forever. The present, a time to cherish. Though the future of the universe is bleak, this fate lies beyond eternity. Today, the universe is young, beautiful, and full of mysteries waiting to be unraveled. It is the best time for life, curiosity, and discovery. So rest easy, knowing that the last act of the cosmos is so distant that it may as well never come. For now, our universe is alive, and there is still so much to explore.